Welcome you all. So in today's section we will see how we can find the transfer function from the signal flow graph. So we will find the transfer function from the signal flow graph using Mason's gain formula. T is equal to 1 divided by delta summation k pk del k. So we have to know each terms, that is what is delta, what is pk del k. So T is the overall transfer function of the system. Pk is the forward path gain and K is the number of forward path. Delta is equal to 1 minus sum of individual loop gain plus sum of gain product of all possible combination of two non-touching loop minus sum of all gain product of all possible combination of three non-touching loop. Then del K is equal to 1 minus gain of the loop which does not touch the forward path. So we will see all these terms in problem. So this is our problem. Find the overall transfer function of a system through signal flow graph shown in figure. Okay. So this is the signal flow graph. We know the signal flow graph. So this is our given diagram. So this signal flow graph we have to find the transfer function using the formula T is equal to 1 divided by delta summation k pk del k. So here number of forward path is 2. So forward path is we know from the starting node to the end how many paths are available, that is forward path. So here this straight line is one forward path and starting from node 1, 2, 3 then node 1, 2 then goes to 5 then 6, 7, 8, that is another forward path. This way, this one is another forward path. So in this diagram we have two forward path. So k is equal to 2. By substituting k is equal to 2 we can remove the summation sign, that is T is equal to 1 divided by delta summation k is equal to 1 to 2 pk del k. By substituting the k value, the equation, the formula will be changed to T is equal to 1 divided by delta p1 del 1 plus p2 del 2. So we have to find each terms, that is delta p1 del 1 p2 del 2 and substitute all these terms in this equation of transfer function T. Then you will get the transfer function of the given signal flow graph. So step 1 is finding the forward path gain values, forward path 1 and 2 gain value. So first we have to draw the forward path 1. So this straight line is our first forward path. So draw that straight line as it is. So 1, 2, 3, 4, 5, 6, 7, 8. All the 8 node comes here. Then mark all the gain values. Gain value is the value in between two nodes. So write all the gain values. Then write overall gain value of the forward path by multiplying all the gain values in the forward path. So in this forward path we have gain values 1, G1, G2, G3, G4, G5 and 1. So multiply all these gain values to get the gain value of the forward path 1. Now find the gain value of forward path 2 and this is the forward path 2 and we have the gain values 1, G6, G4, G5 and 1. For getting the overall gain value, multiply all the gain values, that is G1 into G6 into G4 into G5 into 1. So that is the overall gain value of forward path 2. Now step number 2 is the individual loop gains. So we have to check how many individual loops are here. So individual loop means the loop which starts from one node and end at the same node. So here we can see, so you have to check the arrow mark. So here we can see from 3, node 3, it starts, goes to 4 and again it ends in 3. So this is our first loop. Then second loop starting from 3, 4, 5 and ends again in 3. And this loop have the gain values G2, G3 and minus H2. And another one loop which starts from node 6, goes to 7 and ends in 6. So this is our another loop. So in this diagram, in this signal flow graph, we have 3 individual loops. So for step number 2, draw all the individual loops separately. So this is our first individual loop, this is our second individual loop, and this is our third individual loop. So draw each individual loop, and for each individual loop then write the gain values. So this is the gain value of P11 is the gain value of loop number 1. That is, multiply all the gain values. So this loop number 1 have G2 and minus H1 as gain values. So multiply that gain values, minus G2 into H1. So this for loop 2 we have the gain values G2, G3 and minus H2. So multiply all the gain values. For loop number 3 we have the gain values minus H3 and G5. Then multiply minus H3 and G5 to get the overall gain value of loop 3. So this is step 2. And for step 3 we have to find the non-touching loop combination. So in this diagram, when we see, for non-touching loop there should not be any common node for that two loops. Okay. So here for loop 1 and 2, when we see loop 1 and 2, we can see common nodes 3 and 4. And when we see loop number 1 and 3, there is no common loops. For loop, this is our loop number 1 and this is our loop 3. So for these two loops there is no common loop. So it is a one combination of non-touching loop. And when we see loop number 2 and loop number 3, there is also no common nodes. So we can take this is as another one combination. So we have two combination of non-touching loop, loop 1 and 3 and loop 2 and 3. So now draw combination 1. So combination 1 have loop number 1 and 3. So this is the loop number 1 and this is loop number 3. Now write the gain value of loop number 1 and write the gain value of loop number 3. And to get the overall gain value of this combination, multiply these two gain values, that is P11 into P31 to get the overall gain value, that is minus G2 H1 into minus H3 into G5 to get the overall gain value of combination 1. Now draw the combination 2. So this is the loop number 2 and this is loop number 3. That is another combination. Write the individual loop gain values, and to get the overall gain value, multiply that two gain values. So here the loop gain value of loop number 2 is minus H2 into G2 into G3, and minus H3 G5 is the gain value of loop number 3. To get the overall gain value, multiply these two gain values. So here we multiply these two gain values to get the overall gain value of combination number 2. Now step number 4 is to find the delta 1 and delta 2 value. So for finding delta 1 and delta 2 value, we know it is given in the formula for delta k. That means if we are finding for forward path 1, then it is delta 1. So delta 1 is equal to 1 minus gain of the loop which does not touch the forward path 1. Okay. So delta 1 is the gain of the loop which does not touch the forward path 1. So here delta 1 is equal to 1 minus gain of the loop which does not touch the forward path 1. So here this is the straight line is the forward path 1, and all the three loops, this is loop number 1, 2, 3, all the three loops are touching the forward path 1, and there is no loop which does not touch the forward path 1. So here delta 1 is equal to 1 minus 0, it is equal to 1. And for delta 2, the formula is 1 minus the gain of the loop which does not touch the forward path 2. And this is our forward path 2, starts from node 1, 2, then 5, 6, 7, 8. This is our forward path 2. So when we see the loop number 1, it does not touch the forward path 2. This is our forward path 2 and this is our loop 1. So loop 1 which does not touch the forward path 2, and loop 2 touches the forward path 2 in node 5. So here we have only one loop which does not touch the forward path 2, that is loop number 1. So the formula becomes 1 minus gain of the loop 1, that is P11. So gain of the loop 1 is minus H1 into G2. So here minus H1 into G2. So delta 2 is equal to 1 plus H1 into G2. Now we have to find the delta value. So delta value, we know the formula 1 minus sum of the individual loop gain plus sum of the gain product of all combination of two non-touching loop. So here to get the delta value, add all the individual loop gain values. So this is the individual loop 1 gain value, this is the gain of the loop 2, and this is the gain of loop 3. So add all the 3 loops plus sum of the two combinations. This is the combination 1 of two non-touching loop, this is the combination of combination 2 of two non-touching loop. Add that gain values. So 1 minus sum of all the individual loop gain values plus gain of possible combination of two non-touching loops. So then we will get the delta value. Then for finding the transfer function, overall transfer function, t is equal to, we know the formula, t is equal to 1 divided by delta p1 del 1 plus p2 del 2. We have find out all the values, p1 value, del 1 value, p2 value, p2 delta value, delta 2 value. So now substitute all these values in this formula to get the overall transfer function. So here we know the forward path 1 value, p1 value, p2 value, then del 1 value, del 2 value and delta value. Now substitute all these values in this formula of t is equal to 1 divided by delta p1 del 1 plus p2 del 2. Then you will get the overall transfer function of the given signal flow graph. Thank you.